Section 4. Operating System. Introduction. In the previous study section, we learned that computer architecture is a set of disciplines that describe the functionality, organization, and implementation of computer systems. Therefore, in this study session, we will learn about operating system, OS, which is the software that manages computer hardware and software resources and provides common services for computer programs. Learning outcomes. When you have studied this session, you should be able to understand what operating system means, evaluate the various types of operating system, know the component of operating system. Operating system. For hardware functions such as input and output and memory allocation, the operating system acts as an intermediary between programs and the computer hardware, although the application code is usually executed directly by the hardware and frequently makes system calls to an OS function or be interrupted by it. Operating systems are found on many devices that contain a computer, from cellular phones and video game consoles to web servers and supercomputers. Examples of popular modern operating systems include Android, BlackBerry 10, BSD, Chrome OS, iOS, Linux, OS X, QNX, Microsoft Windows, Windows Phone, and ZOS. The first 8 of these examples share root in UNIX. Types of operating systems: single and multitasking. A single tasking system can only run one program at a time, while a multitasking operating system allows more than one program to be running in concurrency. This is achieved by time sharing, dividing the available processor time between multiple processes, which are each interrupted repeatedly in time slices by a task scheduling subsystem of the operating system. Multitasking may be characterized in preemptive and cooperative types. 1. Preemptive multitasking. The operating system slices the CPU time and dedicates a slot to each of the programs. Unix-like operating systems, e.g. Solaris, Linux, as well as Amigaos, support preemptive multitasking. 2. Cooperative multitasking is achieved by relying on each process to provide time to the other processes in a defined manner. 16-byte versions of Microsoft Windows used cooperative multitasking. 32-byte versions of both Windows NT and Win9X used preemptive multitasking. Mac OS prior to OS X also used to support cooperative multitasking. Types of operating systems: single and multi-user. Single-user operating systems have no facilities to distinguish users but may allow multiple programs to run at the same time. A multi-user operating system extends the basic concept of multitasking with facilities that identify processes and resources, such as disk space, belonging to multiple users, and the system permits multiple users to interact with the system at the same time. Types of operating systems: distributed. A distributed operating system manages a group of distinct computers and makes them appear to be a single computer. The development of networked computers that could be linked and communicate with each other gave rise to distributed computing. Distributed computations are carried out on more than one machine. When computers in a group work in cooperation, they form a distributed system. Types of operating systems: templated. In an OS, distributed and cloud computing context, templating refers to creating a single virtual machine image as a guest operating system, then saving it as a tool for multiple running virtual machines. The technique is used both in virtualization and cloud computing management and is common in large server warehouses. An operating system is a program that acts as an intermediary between a user of a computer and the computer hardware. Types of operating systems: embedded. Embedded operating systems are designed to be used in embedded computer systems. They are designed to operate on small machines like PDAs with less autonomy. They are able to operate with a limited number of resources. They are very compact and extremely efficient by design. Windows CE and Minix 3 are some examples of embedded operating systems. Types of operating systems: real-time. A real-time operating system is an operating system that guarantees to process events or data within a certain short amount of time. A real-time operating system may be single or multiple tasking, but when multitasking, it uses specialized scheduling algorithms so that a deterministic nature of behavior is achieved. Components of operating system. The components of an operating system all exist in order to make the different parts of a computer work together. All user software needs to go through the operating system in order to use any of the hardware, whether it is as simple as a mouse or keyboard or as complex as an internet component. Kernel. With the aim of the firmware and device drivers, the kernel provides the most basic level of control over all of the computer's hardware devices. It manages memory access for programs in the RAM. It determines which programs get access to which hardware resources. It sets up or resets the CPU's operating state for optimal operation at all times, and it organizes the data for long-term non-volatile storage with file systems on such media as disks, tapes, flash memory, etc. Program execution. The operating system provides an interface between an application program and the computer hardware, so that an application program can interact with the hardware only by obeying rules and procedures programmed into the operating system. The operating system is also a set of services which simplify development and execution of application programs. Executing an application program involves the creation of a process by the operating system kernel, which assigns memory space and other resources, establishes a priority for the process in multitasking systems, loads program binary code into memory, and initiates execution of the application program, which then interacts with the user and with hardware devices. Interrupts. Interrupts are central to operating systems as they provide an efficient way for the operating system to interact with and react to its environment. The alternative, having the operating system watch the various sources of input for events polling that require action, can be found in older systems with very small stacks, 50 or 60 bytes, but is unusual in modern systems with large stacks. Interrupt-based programming is directly supported by most modern CPUs. Interrupts provide a computer with a way of automatically saving local register context and running specific code in response to events. Even very basic computers support hardware interrupts and allow the programmer to specify code which may be run when that event takes place. A program may trigger an interrupt to the operating system. If a program wishes to access hardware, for example, it may interrupt the operating system's kernel, which causes control to be passed back to the kernel. The kernel then processes the request. If a program wishes additional resources or wishes to share resources such as memory, it triggers an interrupt to get the kernel's attention. In both segmentation and paging, certain protected mode registers specify to the CPU what memory addresses it should allow a running program to access. Attempt to access other addresses trigger an interrupt which causes the CPU to re-enter supervisor mode, placing the kernel in charge. This is called a segmentation violation, or SegV for short, and since it is both difficult to assign a meaningful result to such an operation, and because it is usually a sign of a misbehaving program, the kernel generally resorts to terminating the offending program and reports the error. Disk access and file systems. Access to data stored on disk is a central feature of all operating systems. Computers store data on disk using files which are structured in specific ways in order to allow for faster access, higher reliability, and to make better use out of the drive's available space. The specific way in which files are stored on a disk is called a file system and enables files to have names and attributes. It also allows them to be stored in a hierarchy of directories or folders arranged in a directory tree. Various differences between file systems make supporting all file systems difficult. Allowed characters in file names, case sensitivity, and the presence of various kinds of file attributes makes the implementation of a single interface for every file system a daunting task. Operating systems tend to recommend using and so support natively file systems specifically designed for them. For example, NTFS in Windows and ext3 and RacerFX in Linux. Support for file systems is highly varied among modern operating systems, although there are several common file systems which almost all operating systems include support and drivers for. Operating systems vary on file system support and on the disk format they may be installed on. Under Windows, each file system is usually limited in application to certain media. For example, CDs must use ISO 9660 or UDF, and as of Windows Vista, NTFS is the only file system which the operating system can be installed on. Device drivers. A device driver is a specific type of computer software developed to allow interaction with hardware devices. Typically, this constitutes an interface for communicating with the device through the specific computer bus or communications subsystem that the hardware is connected to, providing commands to and or receiving data from the device, and on the other end, the requisite interfaces to the operating system and software applications. It is a specialized hardware-dependent computer program which is also operating system specific that enables another program, typically an operating system or application software package or computer program running under the operating system kernel. to interact transparently with a hardware device and usually provides the requisite interrupt handling necessary for any necessary and synchronous time-dependent hardware interfacing needs. Study section summary. In this study section, 1. Operating system acts as an intermediary between programs and the computer hardware. 2. Operating system can be categorized into single, multitasking, single, multi-user, distributed, templated, embedded, and real-time operating system. 3. The kernel, program execution, interrupts, memory management, device drivers, disk access, and file systems components of the operating system all exist in order to make the different parts of a computer work together. This is the end of study section 4. Thanks for listening.